Hello everyone, my name is Tanisha Chaudhary and in today's session I'm going to discuss about multiplexer, which is a very important topic of digital electronics. We'll start with the basics of a multiplexer. Why do we need a multiplexer? See the applications of it and finally design a multiplexer step by step. Let's start with the definition of a multiplexer. As you can see, a multiplexer is a combinational circuit which accepts input from multiple input lines and allows data to pass through a single output line. So here the important terms are combinational circuit, multiple input lines and single output line. So what is a combinational circuit? As we know that there are two types of logical circuit. One is the combinational logical circuit and the other is the sequential logical circuit. The difference between the two is that a combinational logical circuit does not possess a memory element, whereas a sequential circuit possesses a memory element. So a multiplexer is a time-independent circuit, which means that the output does not depend upon the previous input, but it depends only and only on the present input. So the next important point is that a multiplexer is a circuit having multiple input lines and a single output line. So let me draw a diagram of a multiplexer to make you understand more properly. So suppose this is a multiplexer. So it has many input lines and only one output line. From this many input lines, only one input line can be selected and directed to the output at a time. So this process of selecting one input line at a time is called as multiplexing. Now, as only one input line can be directed to the output at a time, we need a mechanism to decide which input line will be directed to the output at what instant or at what situation. And for such reason, we have some additional input lines which are known as the select lines. So let's see the logical block diagram of a multiplexer to understand it more clear. So this is the block diagram of a multiplexer. So in general, there are 2 raised to the power n input lines. Why 2 raised to the power n? I'll explain it shortly. And these are the select lines. Now, selection of a particular input line is controlled by the select lines. And there are total n select lines. And we know that in binary, if there are n bits, then the total number of combination is 2 raised to the power n. So for n select lines, there will be total 2 raised to the power n input lines. Another important thing to note here is that there can be less than 2 raised to the power n input lines, but there cannot be more than 2 raised to the power n input lines. Since it's a multiplexer, it will always have one output line. This multiplexer is named as 2 raised to the power n cross 1 mux. Why 2 raised to the power n? Because here this 2 raised to the power n indicates the total number of input lines and this 1 indicates the one output line. Now, multiplexers are used in various fields where data need to be transmitted. Multiple data needs to be transmitted using a single line. So following are some applications of the multiplexer. So multiplexers are used in communication system. They are used in telephone network. They are also used in computer memory. In fact, the efficiency of a communication system is increased using a multiplexer. So these are some basics of a multiplexer. Now let's take an example and design a multiplexer and see how it actually works. So let me take 2 select lines and name them as S0 and S1. So here the value of n is equals to 2 since I have taken 2 select lines. And we know when there are n select lines, the maximum number of input lines can be 2 raised to the power n. So it will be 2 raised to the power 2 which is equals to 4. So there will be total 4 input lines. So these are my 4 inputs. 1, 2, 3 and 4. Let me name them as I0, I1, I2 and I3. And there will be one output line. Let me name it as Y. So this multiplexer is named as 4 cross 1 mux. Why? Because it has 4 input lines and 1 output line. So this is the block diagram of the 4x1 mux. Now let's draw the truth table of this multiplexer. Now since we have 2 select lines, S1 and S0, and 1 output line, that is Y. As we have used 2 select lines, there will be 4 combinations, that is 0, 0, 0, 1, 1, 0 and 1, 1. Now for the first combination of S1 and S0, that is when S1 is equals to 0 and S0 is equals to 0, the input I0 will be directed to Y. So in this output column, for the first combination, we'll write I0. Similarly, for the second combination of S1 and S0, input I1 will be directed to Y. For the third combination of S1 and S0, input I2 will be directed to the output. So we'll write here I2. And for the last combination, input I3 will be directed to Y. So this is the truth table of the multiplexer. Now from this truth table, we can write the characteristic equation or output equation of the multiplexer. We are going to write the characteristic equation in SOP form. And in digital electronics, SOP stands for sum of product. In this form, different product terms of input are summed together. The important thing to remember about SOP form is that in SOP form, logical 0 is taken as complement, whereas logical 1 is taken as non-complement. Now, as you can see in this table, for the first combination of S1 and S0, both the values are 0. And we know that in SOP form, as I have just mentioned, logical 0 is taken as complement. So it will be, so the first condition will be S1 complement and S0 complement. For the second combination of S1 and S0, it will be S1 complement as it is 0 and S0 as it is 1. Similarly, for the third combination, the condition will be S1, S0 complement, and for the last combination of S1 and S0, the condition will be S1 and S0. Now we are going to write the output equation of the multiplexer. So now writing my output equation. So from the table, as you can see, the first condition is S1 complement, S0 complement. So S1 complement, S0 complement, and in this condition, input I0 will be directed to the output. So I0. The second condition will be from the table S1 complement, S0, I1. The third condition will be S1, S0 complement, I2. And the last condition will be S1, S0, I3. So this is the output equation. Whatever we have discussed in the table, we have written it in the equation form. From this equation, we can draw the internal circuit of the multiplexer. S0 passes through a NOT gate or inverter, it becomes S0 complement. So this is S0 complement and this is S0. Similarly, when S1 passes through a NOT gate or inverter, it becomes S1 complement. This is S1 complement and this is S1. Now, I need all the combinations of S1 and S0, for which I will be using an AND gate. And since there are 4 different product terms in the output equations, I will be requiring 4 AND gates. So these are my 4 AND gates. So the first condition is S1 complement and S0 complement. So this is S1 complement and this is S0 complement. The second condition is S1 complement, S0. So this is S1 complement and this is my S0. The third condition is S1, S0 complement. This is S1 and this is S0 complement. And the last condition is S1 and S0. So this is my S1 and this is S0. The circuit is not yet completed because I have not introduced the inputs. So this is my input I0. I0 goes with S1 complement in S0, that is the first AND gate. This is I1. I0. I1 goes with the second AND gate. This is I2. I2 goes with the third AND gate, and I3 goes with the fourth AND gate. Now all these expressions must be passed through an OR gate because of the positive operator present in the output equation. So they should be passed through an OR gate. So this is my output Y. Now let me draw a block like this one. So this is the internal circuit of the multiplexer. So this is the block from where we have started. So finally we have obtained the internal circuit of the block here. I hope the internal circuit of the multiplexer is clear, and now you can design a multiplexer. So finally we have come to the end of this video. If you like this video, hit the like button and please subscribe to my channel. Thank you.